Hello, welcome you all to yet another session on process control. This is Ajit B. Singh and I am here to tell you about some terminologies used in process control. In today's session, we will be discussing some terminologies like continuous and batch process, transfer function, self-regulation, degrees of freedom, servo and regulator operations. Now we shall move on to these discussions. Now, as we see the definition of continuous process, it states that the materials or work flows more or less continuously through the plant apparatus while being manufactured or treated. Let us consider a packaging section of any industry. It doesn't stop until or unless any command is given for termination. Similarly, a conveyor on airport baggage delivery is another good example. Now, as we see the definition of batch process, the materials or work are stationary at one physical location while being treated. Let us consider a raw mill in cement plant. The materials are filled inside the raw mill for crushing. The raw materials leave the raw mill once it's crushed to powder and remains till the job is done. The new raw materials enter the mill as the next batch. You can find these kind of systems in security working shifts also. Now let us see about transfer function. Transfer function is nothing but a mathematical equation which describes best about the relation between input and output of the system. Hope you all would have known about transfer function while learning control systems. From the basic definition, transfer function is the Laplace transform of output by input at zero initial condition. It gives us the knowledge about the system dynamics in terms of order and type of the process. Now let us see what is mathematical modeling of any process. As we were discussing above, the method of obtaining the transfer function of a process is known as mathematical modeling. It helps us to analyze the behavior of the process considering the variables involved in the process. This activity is called as modeling. There are two types of mathematical modeling procedures. One is experimental modeling and the other is theoretical modeling. Experimental modeling requires a physical setup and observation of output with respect to input. Theoretical modeling does not require any kind of physical setup, but it requires the representations like chemical equations, algebraic or differential equations explaining mass balancing, etc. This can be used for modeling in theoretical approach. Mathematical modeling is used for improving the understanding of the process, optimizing the process design with respect to equations, and to design and develop control algorithms for regulating the process. Hope you got an idea about the mathematical modeling and the use of mathematical modeling. Now let us move on to self-regulation. Self-regulation is the tendency of any process to correct itself without any external interventions. Let us take an example of a human child. The child does not know that heat burns. Once it touches any hot object, it realizes that heat feels burning and will never get back to any hot object after that. It autocorrects itself to be safe. Similarly, some processes will exhibit this correcting nature and are termed as self-regulating processes. This will improve the stability of that process. Now let us move on to degrees of freedom. Degree of freedom is nothing but the independent variables that must be specified to describe a process completely. It can be given by an equation, which is the difference between the number of variables describing the system and the number of defining equations in the system. Degree of freedom tells us about the nature or the state of the process. Hope you gain some knowledge on degrees of freedom. Let's see about servo and regulatory operations. Each and every process has a set point and a load variable along with the output or controlled variable. When there is a change made in set point to attain the output of any process, then it is called a servo operation. A good example would be the turning of steering wheel in an automobile. It can also be said as the tendency of any process to follow the set point is called as servo operation. Servo operations are quite common in batch processes. When coming to regulator operation, the load or disturbance variable is changed in order to maintain the output of the process. It can also be said that the tendency of the process to follow the load variable is called as regulator operation. A good example of regulator process would be a thermal process, for instance, an iron box.
Thank you for watching this session. Hope to see you all again in the next series on process control.